The third chapter of FREP is the water service chapter. We might say that this is one of the most complex chapters from the three, but this chapter forms a basis to conduct a hydraulic performance assessment of irrigation systems. I will shortly present the structure of the chapter in the rapid appraisal procedure. I will talk about why we call it sequential assessment, and I will present the internal indicators to evaluate the water service. The water service chapter is the physical assessment of the infrastructure, meaning that it scrutinizes the engineering shortcomings of the irrigation scheme. It starts from the water intake structure through the entire infrastructure to the drains. What makes a conceptual difference in performance evaluation between open canal and pressurized irrigation system is the fact that performance of pressurized irrigation systems can be evaluated only virtually. In order to deliver sufficient amount of water, we need to analyze the flow and the pressure conditions. These are not easily observable characteristics. Also, the pressurized systems form one complex infrastructure, each part of it heavily dependent on the performance of other parts. The water service appraisal is based on the concept that proper operation maintenance can significantly increase the system's lifespan and realize gains, thus reducing the further investment needs. So, in first step, we have to assess the conditions and the performance level of each single component of the system. Similar to the management chapter, the water service appraisal is a stock-taking exercise, having both open-ended questions and performance scoring to obtain internal indicators. When we mention that it's sequential assessment, we mean that it phases the infrastructure by its components. The first is the intake structure, then pump station. The water distribution is through the pipelines, including main and branch pipes, and reaching the hydrants as final distributaries. After the on-farm water use, it includes also the appraisal of drains. It is important to mention once again that RAP is designed for system-level appraisal. It does not extend to on-farm infrastructure. The key questions and dimensions which are applied to each component, each part of the irrigation system, what we would like to investigate, that what are the main characteristics of the system, and what are the basic principles of irrigation scheduling, whether it is rotational, volume-based, crop demand-based, or any other. Also, how does the system perform in terms of how the proposed system part achieve its objective? For example, is the pump station sized properly to provide sufficient water in peak period? Then how is the operation arranged? Like, is there any written rules on operation? Finally, we would like to know how is the maintenance organized? Does it correspond to the manufacturer recommendation, and is it, for example, well documented? Water service appraisal is always based on field visit. Experts who are responsible to conduct RAP must visualize the field and observe it on spot. The methodology itself is built on the research method of field observation. Not all shortcomings are evident though. For example, if the buried pipe is cracked underground, it's difficult to recognize it by simple observation. Therefore, the compiled survey of the water service chapter helps users to better scrutinize each part. Consequently, the water service chapter is a systematic stock-taking of external and internal factors potentially affecting the performance. Similar to the management chapter, water service appraisal is a combination of open-ended questions and evaluated scoring plans. The internal indicators are the results of the chapter. Each dimension, let's say each question what we discussed, are evaluated through several composite indicators. The composite indicators highlight which aspect underperform compared to the others. Indicators can be broadly interpreted. Therefore, it is desirable to assess the water service in the context of the open-ended questions and internal indicators. I would like to highlight the fact that recommendations to improve water service can be soft measures and hard measures. Like soft measures are, for example, the better irrigation scheduling, well-crafted maintenance protocol, the coordination of employees, or hard measures can be the requirement of complete re-engineering, repairing broken items, or replacement of the infrastructure. The REP is based on the service concept. As the initial objective says, REP has been designed under the assumption that all employees of an irrigation project only have their jobs for one reason: to provide service to customers. And in our case, customers are the farmers. So basically, each part of the infrastructure is integrated into the term of service. Like this, it provides a comprehensive assessment. REP requires users who looks beyond individual pieces, how the pieces can be manipulated and rearranged as part of the complete process that provides good service and high efficiency. The service is described with 5 indices: flexibility, reliability, equity, adequacy, and control of flow. These definitions will be further discussed by my colleague. The service indicators, similarly to the other internal indicators, are scored at 5-point Likert scale that follows a strict scoring plan. These particular indicators are scored by both users and the management. It may be evident that perception of the farmer about irrigation service will be completely different from the perception of a manager. Therefore, the first and most important step is to eliminate the difference between users and service providers' perceptions. Generally, we can conclude that rehabilitation and modernization is not only about engineering, but more integrated and holistic processes that aims to increase the satisfaction of farmers and improve sustainability. Thank you for your attention, and I would like to give the floor to my colleague Fatih Labdi, who will give a more in-depth presentation about the service indicators.